have just two loops of paper stuck together. I'm just going to cut through the center of each one, and you might be surprised at what's going to happen. Here it is. A square. Lovely little square. Okay, now what if instead of those two loops like I had before, I had two Mobius strips? Looks a lot cooler, but what's the point? So I just got these two Mobius strips, and they've been twisted in opposite directions, and I glued them together at right angles. And I'm going to go ahead and cut through them just like I did with the circles. It's a little bit harder to cut. So this is after one cut. I cut through the blue one, now I'm going to cut through the yellow one. And look what we end up with. Two hearts, two interlocked hearts. This really bothers me because the heart shape is not really a mathematical shape that I'm familiar with. I can handle the square. What's so mathematical about a heart? So I thought about it and thought about it and thought about it, and this is what I came up with. The square that appeared previously is just a regular shape with 4 right angles and 4 straight lines. So I thought to myself, is it possible in 2 dimensions to build a shape with 2 right angles and 2 straight lines? Well, here's 1 right angle and 2 straight lines. But any way you try to join these lines, you would have to curve them because they're perpendicular, right? So that looks really weird. I don't know if that's possible. But you know, this is an oval. It's like a lemon. It's like a lemon shape. But suppose in some world these 2 lines were straight lines and those 2 angles were right angles. Then this random thing would satisfy the condition of a shape with 2 right angles and 2 straight lines. So I'm going to try to show you guys that it actually is possible, just not in 2 dimensions. So to illustrate my point a little bit better, I've actually built 2 right angles out of paper. And I'm going to try to join my 2 right angles, such that those 2 straight lines actually become 1 straight line, and those 2 straight lines also actually become 1 straight line. So the first thing I'm going to do is I'm going to actually tape these together because I feel like that's a good place to start, right? Just trust me. Okay, so you can even see where I put the tape because I sort of I passed them over each other just to make sure that I wasn't messing around. Like this is 1 straight band of paper. Now I need to join those 2. Okay, so here's the idea. I'm actually going to hold this down. If you haven't guessed it by now already, the shape that's going to come out of this is the heart shape. So this is how you do it. You hold 1 right angle down like this, and you're just going to twist the top like that. Okay, so we got like half a heart. And then you just join these 2 lines together. So I'm going to go ahead and tape them so it's more clear. Okay, here it is. So it's not beautiful, but you can see it is a heart shape. And it does have 2 right angles, because that's what I started with. And it has 2 straight lines, because this is a band of paper. And it's a straight band of paper. And I haven't like made any cuts in it, or like stretched it, or distorted it. Like they're both straight bands of paper. And they're joined by 2 right angles. 2 circles gave us 4 right angles and 4 straight lines. 2 Mobius strips still gave us a total of 4 right angles and 4 straight lines, because 2 and 2. So that's pretty weird. Even though this problem was impossible to solve in 2 dimensions, it was possible to solve in 3 dimensions, because by making a twist, I sort of lifted the lines off of what they would be in the plane, and I sort of took advantage of the 3rd dimension. So that makes me wonder, if this problem can be solved by sort of tapping into a higher dimension, how many more problems can be solved by sort of tapping into higher dimensions? Thank you so much for watching.